particle moves in a straight line so that any time t seconds, its acceleration is given by this expression here. It is known that the initial velocity is 10 meters per second and that the particle is initially 5 meters to the right of an origin O. We want to find expressions for the velocity and displacement at any time t. Well, we know velocity is the integral of acceleration. So that's going to be the integral of 3t squared minus 12t plus 5. So that's going to be 3t cubed divided by 3 minus 12t squared divided by 2 plus 5t plus some constant, which I'll call c1. And then if we tidy that, that's t cubed minus 6t squared plus 5t plus c1. Now we're told in the question that v is equal to 10 when t equals 0. Now if t is equal to 0, all of these terms here are 0. So that must mean that c1 is equal to 10. And therefore the velocity is going to be t cubed minus 6t squared plus 5t plus 10 meters per second. Now for the displacement, that's equal to the integral of velocity dt. That's going to be t to the 4 over 4 minus 6t cubed over 3 plus 5t squared over 2 plus 10t plus some constant. Tidying that, we get t to the 4 over 4, take away 2t cubed plus 5t squared over 2 plus 10t plus c2. But we're told that s is equal to 5, and it's positive 5 because it was to the right of O when t equals 0. Remember, when t is equal to 0, all of these terms here will be 0. So it must be that c2 is equal to 5. And so we have s is t to the 4 over 4 minus 2t cubed plus 5t squared over 2 plus 10t plus 5 meters.